My name is Duda. I'm the head of the open session here. I also run the software team at Arista. And you can tell I'm a real software guy because we're just getting started and we're already 10 minutes late. So the open session here is about everything with open in its name. Things like OpenStack and open virtual networking. And this is really about how do we create tools that are broadly shared across the ecosystem to enable services that operate cross-vendor, cross-deployment, cross-tenant, network-wide. And kicking us off, I'd like to introduce my friend and colleague, Sukhdev Kapoor. He's an SDN architect for Arista, and he's done a lot of work in the OpenStack community, looking at how we can take some of the key value adds of OpenStack and apply them to the physical world, physical servers and physical networks in the context of the OpenStack Ironic project. Thank you, Sukhdev.
So when you think of cloud, most of the people think about VMs. And there is an actual, real serious need for certain services for bare metals. And as we see more and more demand for bare metal deployments in the similar fashion as the VMs are deployed in the cloud is coming up. And in this session, I'm going to cover the bare metal deployments as we have done it in OpenStack. And I will talk about how does it work and what is available in terms of bare metal deployments in the OpenStack. So a bit of history. For those who don't know, Ironic is a service in OpenStack which deals with bare metal deployments. And it's a fairly new service, and it started in 2013. And it started as a very elementary private cloud-based deployment for bare metal, and it worked well. And the idea to provide it in a public cloud came quite early, but it was sort of deferred. It was too hard to do. That was the reason. And as I go through, you will see what were the difficulties. And we've sort of come over them, and we've solved them. And now we are at a point where we can make it as a reality. So when you deploy bare metal servers on a flat network, that means there's no traffic isolation. When a bare metal server is booting or is cleaning up or running, it has full access to the control plane. And that's really a no-no in a public cloud. It's okay for small deployments in a private deployment scenario for a single tenant type of deployments, but it doesn't work well in the public cloud. So that's the challenge. And that's what we took upon to solve. So a little bit of a background. So the rack space was the first one to come out with a project called On Metal. And that's what they took. They wanted to take the bare metal deployments in the public cloud by actually utilizing OpenStack services, the Neutron networking, and more specifically ML2 plugin. But it was extremely super hacky. They made it work, it would work, but it was very kludgy. And the only way you could take advantage of it was to replicate it. You take the whole thing, copy it in your own environment, and be able to deploy it. So it was not really truly multi-vendor where different people can all participate in the same deployment. So we as Arista, we took upon the challenge. We said, okay, we will solve it because several of our customers were looking for that. We were asked, like SAP being the first one, they came to us and they said, we need to address this, and we have a real need for it. In fact, Stefan has a session later on this afternoon. He will talk about how they're using this service to build their public cloud. And so we sort of collaborated with SAP, HP, and few others in the community to come up with the solution. And the idea was, let's do it all the way. Let's do it right. Let's do it a completely vendor agnostic way. And let's be able to offer multiple topologies and use the NOVA the way it works for regular VMs compute. So the whole idea was, we want to be able to instantiate bare metal servers exactly the way the virtual machines are instantiated, and be able to get the exact same security levels and exact same level of multi-tenancy. So that was the goal, and that's what we were trying to do. Okay, so as a solution, so the first thing we did was we said, okay, let's utilize the ML2 plugin, which is available in the Neutron. Why that works? Because it's already provides a multi-vendor. It's a multi-vendor solution, and it's widely deployed. Tens and hundreds of vendors and solutions are built around that, and we said let's utilize that, and then enhance the Ironic service, the bare metal service, to interface with ML2 plugin and provide the necessary information into the Neutron so that the logical ports and the physical ports can be plumbed together. So today, in a virtual world, NOVA provides that information through what's called binding profile, whereby Neutron will create a port, logical port on a network, and NOVA will provide the exact information about which hypervisor a VM is placed on, and thereby taking that information, the physical and the logical part is plumbed. So similar information is needed for the bare metal servers. In bare metal server, there is no hypervisor, there is no intelligence as to where this compute server is sitting. So therefore, the physical connectivity information needed to be provided by Ironic. So that's the enhancement we made. And also, NOVA needed to be modified, because NOVA today, in a virtual world, when it will communicate with the Neutron, it will also provide the binding information as to which hypervisor the VM is placed on. So that information is missing. So therefore, NOVA will request the creation of a logical port, but do nothing else. So let Ironic take over. So that's how we sort of put these pieces together. And now I'm going to talk a little bit of architectural detail. So the key is, in a multi-tenancy environment, we need to make sure that a given tenant does not poke around into the control plane. So when a server is booting up, okay, it has access to the TFTP server, it has access to DHCP server, which is where it's PXE booting from, right? So we wanted to make sure that happens on a completely separate network, not on a tenant network, so that it's a complete private operation. And for that, we decided to use a provisioning network. And this provisioning network is sort of private, which is managed by an admin, and it's not visible to the tenant. So therefore, it's completely secure. So the tenant network is the actual network which the user intends to place the bare metal on once it is available. And the cleaning network, the same way. When a server needs to be shut down, okay, it's taken off the tenant network and is moved on to a private network, which is, we call it a cleaning network, and that's where it's remotely wiped out. So the reason we use these three networks is to completely isolate and provide the security for these servers. Because there is no hypervisor, there is no other middle pieces to deal with it. Okay. So here are the main component which play into make this work. Ironic, I mentioned, is a bare metal server. Nova is the main compute service. So all the virtual or the VMs, they are instantiated by Nova. And Neutron, and more specifically ML2 plugin, is the networking service. So that's the what which is creating the virtual networks and, and is plumbing the back end. And on the top right-hand side, that's where the multiple vendor drivers exist. So the way ML2 plugin architecture works is that you can have multiple vendors playing into the same deployment. For instance, you can have Arista and Cisco, one cluster in the OpenStack deployment being managed by Arista, another one by Cisco, and there will be two vendor drivers in the play, which are actually provisioning the back end of the hardware. So here, I'm going to just give you a very quick and brief walkthrough of how this whole process works and how it is completely isolated. So tenant network gets created by the user, whichever network they want to use. We will call it a blue network. And the provisioning network is an admin network. So that's what I was mentioning earlier. It's a private network. It's not visible to anybody, right? And typically, if you want to launch a VM in an OpenStack world, you will go to a portal and you will select, you will say instantiate an instance, and you have flavors. You can pick a small, large, whatnot. And now you will also see a bare metal flavor. So either you pick, if you pick a virtual machine, Nova kicks in and it sends a request to Neutron to create a logical port for it. And then it also sends the profile information that which hypervisor it has placed that VM on, and that's how Neutron can plumb. The back end, the vendor drivers can plumb the end-to-end pieces. Whereas in case of a bare metal, it's exact same path. The only difference is, in this case, the port is created but not bound. So the Nova will essentially take the similar path, but it will tell Neutron, do not bind this port. And the ironic will instead take over. In order to bind the port, in order to create the physical connectivity, the vendor driver needs to know exactly which switch, which port the bare metal host is connected, because it's powered off. There is no intelligence available. So all you have is a cluster full of powered off servers which you're trying to bring alive. So the ironic is the service which actually provides that physical connectivity information. And when it does a create port, so it's a separate logical port which is being created on a provisioning network. And once that request comes in, so that's where the actual binding takes place. And the binding is where the vendor driver comes in and configures the switch, which is the physical information is provided in the binding profile by the ironic. Okay. So by doing so, the proper VLAN or VXLAN or whatever network topology needs to be used. So now the bare metal connects to the provisioning network. This is where it gets the IP address from the red network, which is completely private network, and it has access to the TFTP server. It goes to the TFTP server, pulls the RAM disk image, brings it into local RAM, and then it power cycles again to reboot it with that image. And once it's up and operational, at that point it establishes communication with the ironic conductor to let it know what state the server boot up as, because this could be a fairly long process depending upon what is being booted or what kind of image is being booted up. So once ironic knows the server is ready and it reached to a final stage, at that point it will delete delete the port from the provisioning network, and same again, the vendor drivers come into play, and they will unprovision, and then now the server is up and ready to go, and it's disconnected from the private network, and now an update port. So initially, when Nova had started the boot process, it had created a port, but it had never bound it. So this is the time now Ironic will come in and will say, okay, update the port and now bind it, and it provides that information, the physical connectivity information again, and now the server goes and gets connected to the actual tenant network. So that is the entire process which it takes for a bare metal to take from a purely cold state all the way ready and engaged in the tenant network. Okay. So which is fairly similar from the end user point of view. It's a fairly similar process. Behind the scene, a lot of moving parts, and that's why this whole work was deferred until we came in and we said, okay, let's get this thing done. So one thing, as I mentioned, in case of virtual machines, because hypervisors exist, because a lot of intelligence exists, so the physical placement information is available. In case of bare metal servers, that's not available. So therefore, that local link information needs to be provided. So we essentially came up with the Python DIT, whereby we will essentially specify which switch, physical switch, where the server is connected, and which port. So essentially that information needs to be passed. Another thing which we did was we created a brand new VNIC type. We call it bare metal. Okay? So typically on a large public cloud, you could have thousands of these VMs and BMs. They're all running in the same cloud on same network or different networks. And the vendors want to be able to filter. They want to change the policies only on the bare metal servers or only on the virtual machines. So it gives them ability to filter. So they can filter different servers based upon the VNIC type. And there's another component which is developed in Ironic, which is called Ironic Inspector. Okay, so what that does is by having a proper configuration, it uses the LLDP to fill that information up. So typically, if you see from a deployer point of view, you have a rack full of powered off servers. They're all connected to the towers. And now people, generally an operator will be sitting there and taking an inventory, which server is connected to which port and so forth. And that physical information needs to be transferred so that it can be plumbed properly. So it's a fairly error-prone process. So what Inspector does is it makes that fully automated. So therefore, the whole operation becomes completely automated. Okay. So with this, you get a full security groups support. Okay. And VM and BM, you can essentially take the same security groups which are defined in Neutron, which are applicable to the VMs, and now you can apply to the BMs. And that's true for all three networks which I talked about. Okay. And typically, unlike VMs, BMs can connect to multiple switches, or they can be lagged or M-lagged. So all these configurations, whether you're a single port or a lag where multiple physical VNICs are connecting to the same switch, or they're connecting to multiple switches. So all of these are supported. And if you're utilizing Arista deployment, we make it even a whole lot simpler. That the left side is all the three components I've talked about it. On the right-hand side, behind the cloud vision, sits the entire fabric, and we have a complete visibility into the physical topology of how and where these switches are. So whether you're launching virtual machines or bare metal machines, because of the visibility, we have fully automated this whole operation. And I'm down to my last slide. So when is this available? So it's coming, it's presently available. A lot of people are testing it. but it's formally going into Neutron Release, which is coming out next month. Okay, so which vendors support it? Arista and HP took the lead on it, so we have it. Cisco is on board, and many other vendors are implementing this thing. Which operators are using it? SAP is the first one. As I mentioned, they're going to have a session that will discuss about how they're building their public cloud using this technology. IBM Software is looking at it. Rackspace is utilizing this, and many other vendors, many other operators are getting on board with this. And again, this is all being done in an open community, open source. So if you want to learn anything, where do you want to start? You want to participate? You want to request changes or whatnot? Come talk to us. We meet every Monday. I chair that meetings, and it's in the open IRC form, OpenStack meeting. And if you want to read up more about it, there are a lot of documentation. You can just Google it, and you will find the team wikis, and there are blueprints which will discuss all of that. So with that, I'm done with my presentation. I'll take question and answer later on. Thank you.
All right, thank you very much, Sukhdev. Next up, we have Kyle Mestery from IBM and Justin Pettit from VMware to talk about OVN, Open Virtual Networking, a fully open, open source SDN controller for virtualized deployments. Cool stuff. Please welcome Kyle and Justin.
I'm Justin.
Hey, good morning, I'm Kyle. So let's see, let's get this going here. So we're going to talk about, as Ken said, we're going to talk about OVN, or as we like to call it, OVN, I think, Open Virtual Networking. So I think before we get into talking about specifically OVN, it's worth talking about, again, the case for network virtualization. And I think yesterday, I know in Nick's talk, he talked about this as well, being one of the building blocks in that nice Lego diagram almost that he had. I think network virtualization is a pretty powerful concept as well. Certainly something that your developers can use very, very nicely as well. It allows it allows the developers to do things and make their entire application stack almost self-provisioning, including the network, by utilizing the concepts of network virtualization there as well. And you can see by the slide that we have up there how, if you look at on the left side, you can see kind of a legacy physical network, how that was set up, and maybe how an application that's running on that, it's running on that physical network infrastructure. But if you look at how maybe a cloud network might look, the components are distributed across the hypervisors. But the nice thing is, from an application developer's point of view, they don't have to understand that these different pieces of their virtual network are distributed. To them, it's just a virtual network that they can utilize pretty nicely. So, what is OVN? OVN is an open source L2 and L3 network virtualization solution for Open vSwitch. It's being developed in the Open vSwitch community as well. As you can see, it provides a lot of features that networking people are definitely familiar with. Logical switches, we do logical routers, both IPv4 and IPv6, security groups, multiple tunnel overlay protocols as well. Logical load balancing was recently added as well. We do Tor-based L2 physical gateways, and we have software gateways as well. The nice thing about OVN is it works on the same platforms that OVS supports as well, and it integrates with a lot of different cloud management systems as well. So you can see we integrate with OpenStack Neutron. There's a lot of work going on there. We have integration with Docker Swarm and Kubernetes as well.
All right, so just want to get into some of the particulars about OVN. As Kyle mentioned, it's being developed in the same community as Open vSwitch. It's vendor neutral, so it started off with some of the core committers to OVS. So in particular, it was some VMware folks, but quickly a lot of other people started joining in. So Red Hat quickly followed, as well as IBM and eBay are involved, as well as a number of other contributors. The design implementation have all been public from the beginning. So when we announced the project, we came up with an architecture that we thought was reasonable. We sent out to the mailing list before there was any code. And we wanted to treat this as a community project from the beginning. So everything happens on the OVS mailing lists. We have IRC channels, and so everything's out in the open. And it uses an Apache license, the same as the OVS user space components, so that people can take it and make modifications. They don't have to share the source code, but or their changes. It's always helpful, but it's not required. So our goals for OVN was to make something that's production quality, just like OVS. We thought it was important to have a straightforward design. We've done some network virtualization projects before. We've seen other people how they use OVS, and that can lead to some serious scale issues if the design is difficult to reason about or is convoluted. And so we have scale goals of thousands of hypervisors. Kyle's going to talk. We have other slides to talk, not today, about scale, but we've been doing some extensive scale testing as well. But Kyle will talk about continuous integration testing that we've been doing with OVN. And then we want to be able to scale to hundreds of thousands of ports. So I want to talk about the architecture a little bit to show why we think that we can reach that. So central to OVN's design are databases. So the original approach to doing network virtualization that we did was to use OpenFlow, but we found that OpenFlow centrally didn't scale particularly well. But databases, this is basically a solved problem. People know how to scale databases. We know how to recreate state in databases. So we have two databases in Oven. There's the northbound database and the southbound database. I'll get into the details in just a minute. And then there's two daemons that run. There's the Oven North D, which is in the middle of the diagram, and then an Oven controller daemon that runs on each one of the hypervisors. And the Oven controller speaks to the southbound database, and then it's responsible for speaking OpenFlow to OVS vSwitchD and OVS DB protocol to OVS DB server. And so we don't have a central OpenFlow controller. Instead, we just do that locally on each hypervisor. So at the top, we have the integration that's done through Neutron or Kubernetes, or whatever the cloud management system is, and it speaks to the northbound protocol or northbound database. And the northbound database has concepts about network virtualization. So it understands things like logical ports, and logical ports are connected to logical switches, and logical switches are connected to logical routers. The southbound database has no concept of these logical concepts. So what Oven North D is responsible for is taking that configuration that was in the northbound database and converting it down into the southbound database that's consumable by Oven controller. So I had mentioned that we're not using OpenFlow centrally, and I won't get into the details, but if anyone's curious, I'm happy to talk about it in more detail later. But what we do is we use logical flows instead of OpenFlow, which uses physical flows. And it's because of the complexity of having to create the view for each one of the hypervisors. You end up having to do n-squared calculations in that central controller. But by distributing it and using logical concepts, we can instead just do n calculations on each hypervisor, and it makes it much easier to scale. And so the Oven controller is responsible for taking those logical flows that Oven North D had built, and then figuring out the mappings and bindings about how to connect to the other hypervisors that are running other Oven controllers. So as I mentioned in the architecture, that the configuration is coordinated through databases, and we're using logical flows instead of physical flows, which we think is going to help scale the project quite a bit better. And one other nice thing about this design is that we have the desired state is separated from the runtime state. So in the northbound database, we have the logical configuration, and if that gets corrupted, the CMS can repopulate that. And then the southbound database, it's a fairly simple transformation going from the northbound configuration to the southbound logical flows. And then the oven controllers then are responsible for the bindings, which is where VMs are located on which hypervisors. And so all of that can be recreated pretty cheaply and easily. And so this design of oven is based on things that we've seen other people try to do, projects that we worked on to do network virtualization. We spoke to a lot of the controller teams on projects that also did network virtualization, asked them, how would you, if you were going to redesign something from scratch, how would you do it? And this architecture we came up with is based on that.
Okay. So next, we're going to talk about something that's pretty near and dear to my heart as well, which is continuous integration and continuous delivery. So you might ask, why are we talking about that at a networking concept, a networking conference here? But I fundamentally believe that this is actually something that the networking community can really benefit from. And certainly when you're going to deploy any of these sort of things at any sort of scale, you have to have a way to do this, to be able to do this. So why would you want to continuously deploy some technology like Oven and Open vSwitch? Well, I think the number one reason is you can enhance the velocity of what you're deploying. I have some slides after this that show this, but with all of the active development that's going on upstream and all of the bugs that are being addressed and features added, but more importantly, stability enhancements that are being done, if you're continuously deploying this, you can take advantage of those features right away. So the other thing is, typical to the project like this, maybe hundreds or thousands, on some weeks, tens of thousands of lines of code might be added to the project. It just depends on what's going on that week. And this code upstream is already being run through continuous integration jobs through Travis CI. Some of that could possibly be improved. I think we could add some more coverage. Coverage is always good. So you're getting the benefit of that coverage that the code's already being run through as well. And the most important thing here, if you're building a team of people to work on something like this, if this is fundamentally important to you, fundamentally important to your business, delivering upstream fast means your developers can work upstream, and you get to consume everything that they do from upstream, and you've just reduced a ton of your technical debt. Now, you'll see in another slide I've got coming up where there are some cases where you do need to provide the capability to carry local patches and things as well. So what does it look like to continuously deliver Oven? So you can see on this chart here, I've got date ranges on the bottom versus lines of code. And you can see, like I had said, it kind of ebbs and flows with how many lines of code that you would be delivering into your systems that are running Oven and Open vSwitch at different times. It's pretty nice. It depends. Some weeks you guys merge a lot of code. That's pretty good. I like that. So on the flip side, you might say, so what would it look like if you were just consuming a release? If you just stuck to the releases of OVS and Oven. Now, Oven obviously wasn't around for some of these previous releases, so the comparison is against OVS itself, but it stands. So if you were just going to consume the releases and said, I'm just taking stable releases of this code and I'm going to deploy it, so now you're looking at anywhere from 40,000 to 150,000 lines of new code being injected at one time. So you better hope you have a pretty good continuous integration system, and you're really good at using Git bisect at this point if you want to try to find where problems are. Yeah, that was a Git joke. No one laughed. Okay. It's still early, I know. So how are we at IBM continuously delivering Oven? You got to come up with a way to do this, right? So what we've done is we've aligned this with the OpenStack CI and CD process as well. And we've got an incredible group of people that are doing this. Certainly I'm not taking credit for this. We have an amazingly talented team that's doing this. So we take advantage of the upstream OpenStack tools. Zool for pipeline management, Nodepool for resource management, Garrett for code review as well. And this allows us to be able to take changes that are going into the upstream repositories, whether that's Garrett in the case of OpenStack or in the case of OVS, GitHub, and we're able to take those changes, pull them down, run them through our own continuous integration, which includes many more things, including running them on physical hardware deployments and things like that, doing lots of performance tests, before we merge those locally and deploy them in production. This also allows us to build our own packages as well, so we can test both package building as well as package delivery and everything like that. So I'd mentioned this. What about local patches? You have to also provide the capability to be able to carry local patches. For one thing, you're going to run into the time, if you're doing this at scale, depending upon what you're doing with it, there's going to be CVEs that are going to show up. You're not going to want to wait for those. You're going to want to be able to deploy those as soon as you find out about them. So also, what about bugs and features that aren't landed upstream? This is actually an interesting one. So if your developers are working on things, whether it's a bug or a feature, let's just say they found a bug in something, some performance increase to get you a 20% improvement in oven controller or something. They want to land that. We want to deploy that right away. So the process we've worked out internally is we have to propose that patch upstream. Once it's proposed upstream, we are then able to propose it downstream as well, and we can carry it locally until it merges. Now depending upon the feedback we get during the review process, we may have to morph the patch a few times, but it does provide us a way to do it, and it really does stress the upstream first nature of consuming these open source projects and really benefiting the broader community by doing that as well, I think. So it's really been a good process for us as well. Okay, I'll change over.
All right, so I just wanted to cover the status of OVN currently. So the next OVS release will be OVS 2.6 that we're planning on releasing in early October. And then it's going to be the first non-experimental release of Oven that we're shipping. And we're making that release coincide with the Newton release of OpenStack, which will be the next OpenStack release. And one thing that we've not been very good at in the past about OVS is releasing it regularly. And so now we've promised that we'll go on a 6-month cadence. So every 6 months, we'll be doing a new release of OVS and OVN. In order to meet some requirements that we needed for OpenStack and for Kubernetes, there was sort of a flurry of activity. Actually, you could sort of see it in Kyle's CI. There was a big spike in August, which was getting ready for the branch for 2.6 for this release of OVN. A couple of the highlights there were that we added L3 gateway support, so we have a software L3 gateway as well as top-of-rack support. But the L3 gateway, we added NAT and load balancing support and IPv6 logical routing. So future work, I'm not going to read all of these, but just to highlight the first two because they're particularly important. Right now we're using OVSDB for the database, and there's been a lot of questions about whether that's the right choice, and we go back and forth about whether that was a wise choice or not. So we're looking at whether we want to switch databases or if we want to add the features that are missing to OVS or OVSDB. And so in particular, what we're missing is the ability to do clustering in HA. We have basic failover now that we added to OVSDB server, so it's, it can be used, but it's not perfect. And so what we're looking at doing in the next release is figuring out if we're going to switch databases or if we are going to add support for things like Raft to OVSDB. And we've actually done a lot of that work, but we don't want to merge it unless we're sure that we're going to have a user of it. Another piece that's pretty critical to the scaling and performance of OVN is currently, whenever there's any sort of change, we have to recalculate all of the states. So that OVN North-D that translates from the northbound database to the southbound database, it's a very straightforward transformation, but it's sort of silly, like if just some logical port got added that you have to recalculate everything. So we're looking at re-architecting OVN North-D so that we can do incremental processing. And similarly for OVN Controller, we want to be able to, if there's just a change, a small change, just be able to make small modifications to the OpenFlow table in OVS as opposed to having to recalculate the whole thing. And then these are just, the other items are just mostly nice to haves that will make it more complete. So resources, we've got, as I mentioned, everything's being done out in the open. We try to be pretty good about the documentation. The architecture is a man page in the OVS code base. And so you can find that online, or if you have the OVS distro, you can get it there. OVN is now part of branch 2.6 and master, so the code's all there. But the various plugins, those are being done separately. So here are links for the Neutron plugin, the Kubernetes plugin, and then the Oven scale test harness, which is something that Kyle's been leading internally to be able to test the scale of OVN. So if you're interested in Oven, we would love to have other people jump in. So as we've mentioned many times at this point, all of it's being done on the OVS dev mailing list. Anyone can subscribe to that. And then we also have pretty regular conversations in IRC on the Pound Open vSwitch channel. We have weekly meetings to discuss OVN status, and then people often just jump in and discuss Open vSwitch or OVN on there as well. And similarly for the Neutron plugin, that's being developed in the open, and there's another IRC channel for that. And with that, that's our presentation on OVN. Be happy to cover questions during Q&A, or if you have other questions during any of the breaks, we'd be happy to talk more about OVN. Thank you.
Definitely. Thanks.
Thank you very much. All right, big thank you to our speakers. Next up, we have two folks from Google, Shaikh and Shakir. We're going to be talking about OpenConfig, which is a vendor-neutral way to programmatically control network switches. And you might be asking yourself, why aren't the network equipment vendors leading this? That's a very good question. But we're really grateful to Google for leading this, and so thank you very much for the partnership.
Thank you, Ken, and thanks for inviting us up. So yesterday, those of you who were here for Nick's keynote, I'm sure most of you were here for that, you heard him talk about operational visibility, programmability for the control and data planes. So we're here to talk about the stepchild plane in networking, the management plane, where we think there's a lot of work to do. So this is a conference about the future of networking. So we have this sort of vision of the future that we've been working towards, that we've dubbed zero-touch networking at Google, that's based on a few key principles that we're basically working towards. One is around automation, which I think is common for many operators who are operating any sort of networks at scale. We're aiming to get to networks that are fully automated. In other words, every operation that can be automated is automated based on an intent API that operators can use. So this means that we need abstractions and software systems that can use those programmatic abstractions to manage the network at scale. The second is we need to have automated detection of any sort of unintended behavior and the ability to roll back when we detect that something's gone wrong. So this implies that we need really fresh, accurate, frequent data from the network, getting back to the visibility point that Nick also mentioned yesterday. We have this notion of safety and security in the network like anybody else. It's interesting that automation so often kind of ignores the need to comply with those policies. So for example, scoping automation so that it doesn't touch more than the expected number of devices in the network, or that automation doesn't roll changes out to the network at a greater rate than what you'd want. So this also requires sort of models of the network, both its structure and its behavior, to basically be able to check for this kind of correctness. And then finally, like any large-ish operator, and maybe even most small operators these days, we run a multi-vendor network. Our user-facing backbone has roughly a half a dozen vendors in it with platforms from multiple generations from those vendors. And we're constantly looking to introduce new technologies into the network to reduce costs, to increase capacity, decrease power consumption, et cetera, et cetera. So we're looking for best-of-breed technology all the time, which means that we need to be able to introduce this technology without a lot of friction. But we do have a lot of issues in terms of the ability to introduce this transparently to the rest of the management stack that we have. So one of the key principles, and this is kind of the focus of what we're doing in OpenConfig, is to be able to introduce new technology in this sort of transparent way without having to completely retool the stack every time we want to bring in a new vendor, for example. So coming back to reality of where we are today, this is sort of the current state of network management. And I'm sure many of you share some of this pain. First of all, this notion of having an intent abstraction doesn't really exist today. So we really don't have well-defined abstractions or APIs that let operators sort of deal with the network at sort of an intent declarative level. The second is, as far as visibility, we're still living with SNMP, and it really doesn't offer the scalability and the data freshness accuracy that we need from the network. So we're stuck with the polling model, proprietary MIB, so obviously we don't have the same kind of data coming back from all the different devices we have. Implementations that are basically from decades ago, really rigid structure, no extensibility. So a bunch of problems with SNMP, and we're aiming to address those in a sort of fundamentally new way of doing network monitoring. Streaming telemetry that you may have seen recent announcements from some of our vendor partners about. The other problem is that we don't have really any APIs to talk to devices that are anything better than what we see today in terms of low-level CLI, right? So essentially, what's offered in terms of programmatic access to devices is this sort of small veneer around what's essentially a per-vendor proprietary CLI. And then finally, all of this means that introducing any new platform in the network is a lot of work in terms of new development effort, new integration effort, and of course, new testing that has to go with all that. So there's a couple of what I would call complementary efforts that aren't really addressing this problem, but do sort of help advance the state of the art. But I often find when we talk to people about OpenConfig that there's some conflation in sort of what these efforts are doing and what we're trying to do in OpenConfig. So for example, automation frameworks, they're fantastic, right? Everybody has their favorite, whether it's Ansible or Chef, et cetera, et cetera. We kind of think of these as fast CLI typing machines, right? So they help you automate, but at the end of the day, what you're doing is still typing CLI commands into the devices, maybe with a layer above that sort of helps you do that translation. But the fundamental problem that you have essentially multiple incompatible interfaces for doing exactly the same thing on different devices still remains, right? They don't solve that problem. The second is that Linux somehow solves our problem. So Linux is fantastic as a substrate for networking. So we've seen countless examples for that. And it does provide a common substrate, but the point is that in a full-featured stack that you might run on a large backbone, for example, you have a bunch of things called protocols and features that you could think of as the apps that run on this substrate, and those still need a common way to be managed. And although we have some examples of maybe smaller scale applications that are available on sort of open stacks, whether it's BGP stack, support for QoS, I don't think we've seen MPLS yet, those things still need common interfaces that we don't have today. So coming to OpenConfig. So what we're essentially doing with OpenConfig is very simple. We want to define a common API for managing devices from a configuration standpoint, and also for getting data back from devices from a telemetry or monitoring standpoint that is uniform across all the vendors that we work with. Right? So this means not just defining the API, but also having a cooperation or collaboration with device vendors where they implement the API directly on devices. So it relieves the burden from operators of actually having to do all this translation and moves it down onto devices directly. So we have one NMS with one way of talking to devices, both for configuration and for monitoring. So a little bit about the organization. It's kind of funny to call it an organization. It's a loose sort of collaboration is maybe a better way to put it. So we have engineers and architects from roughly 15 network operators. It's a very user-driven organization. So in other words, we design the APIs just among operators before we sort of take them forward to our vendor partners to work on implementations. So we really want these APIs and interfaces to reflect the operational needs of users. We structure it as an open source project, so we publish all the data models that we build in GitHub with an Apache license, so it's a very sort of permissive approach. There's actually very little governance in the project. It's remarkable that when there's so much alignment of interests that it's really easy to get consensus, and there's very little sort of friction in this process. The really biggest difficulty is making sure that we have everyone's use cases represented in the models, and that's what we're working towards. One thing you might think we would end up with is essentially data models that represent across devices sort of the least common denominator, but that's not what we're aiming for here, right? We're trying to find or define models or interfaces for managing devices that are what we call operationally complete, which means that from a network operator's point of view, I have all of the tools I need to do what I need to do. I don't want to live with, just because some vendor doesn't happen to support a particular feature yet, I'm going to remove that from the model. Rather, we would have that vendor offer a deviation for the model that makes it clear and explicit that they don't have that feature yet. And hopefully that makes them sort of create a roadmap to get that feature onto the device. So we're not aiming for lowest common denominator. We're rather aiming for operationally complete models. So in addition to models, those of you who are familiar with this sort of modeling landscape with Yang as a data modeling language, for example, maybe seeing in IETF and other organizations, other open source projects, tons and tons of models coming out. Models are certainly part of the problem we're trying to solve, or part of the solution, but there's a whole bunch of other things that come after the models. There's tools of how you actually consume them. A Yang data model by itself is actually pretty useless, right? You can read it. It's meant to be readable, but it's actually not even that readable. What you need are tools, basically, to generate code and software artifacts from the models. You need a set of standards of how the models are built and so that they can interoperate together in some coherent way. When you have models built by lots of different organizations without real coordination, you end up, as a user, from a user point of view, with this mess of models that you don't really know what to do with. And then finally, you need some way to operationalize these models. In other words, turn these software artifacts that come from the data models into device interactions, where I'm actually sending data to the devices, getting data back from the devices in a way that I can use in my NMS. And so the last and maybe crucial part of this is our engagement with vendors. So we have some really great vendor partnerships across OpenConfig with a number of vendors, and Rob is going to talk more about who we've been working with and where the progress is, basically to build native support for these models, both for configuration and for telemetry, directly on devices. And it's also been, I would say, remarkable how much interest and cooperation we've got. I think many folks have a good degree of skepticism about the ability to get vendors to do this, but I think vendors are realizing that differentiating on the CLI for how you configure BGP or MPLS is not really the best way to differentiate your product. So here's just a list of the logos, actually, of the operators who are involved. You can see that we have operators from a number of different segments of the industry. So it's web-scale operators, more traditional telcos, other media sort of companies, Netflix, et cetera, smaller shops like Jive Communications, where Rob was previously. So there's a wide sort of variety of operators involved, and the point is really to get use cases that span the gamut, right? So we're not trying to serve only the needs of one group in the industry. We're really trying to reflect the needs of a bunch of different network operators. And the reason that we, of course, need this collective group is not only to define the use cases, but also to work with vendors. So as a group, we have a lot more leverage with vendors when we say, hey, look, here's a common API that we want to use. We're some of your biggest customers. We'd like your help to go implement this. Okay, so a quick status check on where we are as far as defining the models. This is kind of a snapshot of the current tree, if you will, of the device model that we have in OpenConfig. So the ones in green are things where we've actually published the models already. They're available for download on GitHub. You can take a look at them. We have other models that are drafted. They haven't yet been published. We're reviewing them internally. And then a couple of models that are still to be completed and published. So you can see that we have things like system management, a whole bunch of interface management, layer 2, layer 3, MPLS, traffic engineering, et cetera, et cetera. We have some gaps also. So we've just published an ACL model. That was a gap for a while. We're still working on a QS model. That's going to be a tough one, but I think we're making some progress there. And now I'll hand it over to Rob to talk about how some of the implementations are going to look.
Thanks, Anis. So I'm going to talk a little bit about the kind of overall network management architecture that I think is kind of emerging across multiple operators. I've now had the fortune to work for 3 different operators that contribute to OpenConfig. So I'll kind of talk about, I guess, some of the commonalities that I think we're seeing across those different operators. Now, all of them, of course, have multi-vendor networks. So they all have multiple vendor devices in their infrastructure and need to be able to support those. And what we're starting to see is obviously the support for OpenConfig, giving us the data model, but also some kind of convergence towards the idea that maybe that we also need a common transport protocol there that gives us support for both the streaming data coming from the infrastructure as well as pushing config changes to it. And we're kind of, in OpenConfig, we don't have an official selection, but we're working quite a lot using gRPC, which just went to its 1.0.0 release, to define a protocol there that gives us both the data access that we would like as well as being able to manipulate the data on the device. So we're seeing multiple of the vendors implementing gRPC endpoints on their infrastructure. We then have 2 kind of sides of the NMS stack. We've got the telemetry side, where we're receiving streaming updates from the device with common paths that are within these data models that give us the operational state of those devices. And that kind of telemetry collector infrastructure then feeds a multitude of different services within each operator, depending on what your needs are, be they dashboards, internal TE tools, alerting interfaces, or others. Then on the other side, we have a kind of an abstraction that starts with, as Anis mentioned, something that tells the operator what they actually want the network to do. Not expressed in terms of the config of the device, but expressed in terms of some higher layer abstraction of that. That then pushes through some workflow automation, which does things like this safety implementation that Anis mentioned, or manages which devices this is going to go to, and then down through some config management that pushes the actual changes to the device. But one of the fundamental things about the way we've built the OpenConfig models, linking the state and the configuration together, means that you can actually link the changes that you've made to the operational state of how the network is running, which really helps with trying to figure out the correctness of the configuration change you made or the impact of changes. So this is talking to a system that I actually led building inside Jive, which was my previous employer, which takes OpenConfig and starts to build an actual NMS from it. So we had this intent API, which in Jive is designed to be exposed to people that build services. So we were building voice applications, and this was exposed to people that didn't necessarily know anything about the network, but knew something that they wanted from the network, like an address that needed to be black holed, that was fraudulent, or something like that. So we had a REST API that just presented a common endpoint to those users. There's then some form of service mapping, which actually translates those parameters that you want to give to the external operator into the configuration on the network. And kind of referencing back to the discussion yesterday, right now those mappings are usually written in ambiguous English, but this also gives you a way that we can codify the network design and start to say, here's how we actually map parameters of that service to how the network's going to be configured, which means that your network design is actually much more robust because it's written in code rather than someone who misinterpreted some sentence that somebody wrote because they didn't quite think of the repercussions of it. We then were using OpenConfig as an intermediate format. So obviously you have this transition phase where you have a bunch of devices that might not support OpenConfig, but writing those service mappings into OpenConfig gives you this middle layer that now is vendor neutral. It doesn't mean every time you introduce a new vendor, you don't have to go and remap that configuration layer and find a new storage format for it. You just write some form of translation layer at the bottom. And we had multiple ones of those. Ones that gave us audit framework, ones that gave us translation to Cisco configuration, a gRPC client that would go and apply config changes to our own infrastructure, and then kind of service helpers that do things like OAM, which let you then have service requests, parameters to do with the service, so requests like do an OAM check for this service and run those on the infrastructure so that you can verify that the network is actually running how you would like it to. So this abstraction ends up looking like you have some form of service on the left-hand side. So this is taking something that the NOC might use and just give the parameters that a human needs to use. So things like for a peer, what's the IP, what's their AS set, and then there's a service handler that maps the actual, those parameters into what the configuration is. And then to apply the configuration onto the device, you have whatever, whether it's a direct JSON taking the Yang model, serializing into JSON and applying it via whatever RPC you have, or translating into the CLI configuration, which eventually is something that will go away. So, as Anis mentioned, we've been putting a lot of effort in OpenConfig into tooling around Yang models because the schema is not super interesting, it's not super readable, it's written in Yang, and I would recommend getting counseling before working in detail with Yang. But we've been trying to work on the services that come around that. So things like taking language binding. So can I get this Yang model and develop it into a set of code artifacts that then are easy for a network operator or a network engineer to work with? Because one of the challenges that we have is taking a software-driven world and introducing it to people that know about a bunch of ways to run network distributed systems and making that usable to them. We've also got some tooling and guidelines around how to build Yang models because, again, it's most likely that you don't have an IDE that can help you write them, and there's some need to make that process easier. And then on the right-hand side of this slide, looking at ways that we can have reference implementations that start to give people a way to be able to experiment with the tooling around OpenConfig and see how it works, as well as for us to be able to understand before we get into having baked the thing and written a standard document around it or whatever the next point happens to be, figure out that it works and figure out how operationally that would fit into an NMS stack. And so all of these projects, either they're from some of our vendor partners or they're from organizations or people within OpenConfig, are now publicly available for people to look at. And one of the kind of things that when we started OpenConfig, lots of people were very, very skeptical that we would ever get anywhere with vendors. People think that it's not within the vendor's interests to be able to give you some API because like Anis mentioned, maybe some differentiation there or some illusion of differentiation there. But actually, we've been doing really well, and I think we've worked really closely with a bunch of operators as well as a bunch of vendors to get towards a common view of what's useful and found operational or models of interaction that actually help us drive adoption of them. So we've got streaming telemetry implementations available from multiple vendors, all of which are using the OpenConfig models or as well as vendor models underneath to be able to give those telemetry statistics. We've got native support for a number of our models, so BGP, policy, interfaces across a number of vendors. And those are either in early release or getting towards GA, and we've got additional vendors that we haven't yet managed to agree to talk publicly about. We've then got some adoption of OpenConfig on the optical side as well, where some of the models that perhaps weren't on the kind of device layout before are being implemented. And equally, we're doing a bunch of work where we can with the open source implementation. So Quagga, we've been talking with GoBGP. We're looking to try and add some support into Napalm to be able to give those tools, which people are commonly using in other places, some OpenConfig support. So in summary, we're publishing these data models for monitoring configuration. They're built for users, by users. We always welcome more interaction. We've got growing support in vendor implementations and open source projects. Equally, we would like to work with more teams there. So anyone that has an implementation that you would like to support OpenConfig in, I think we're very open to interacting. And we'd really like more operators involved as well, because we find that the more use cases we can cover, the better the models are, the better the adoption of them can be, and that pushes the effort forward. Thank you very much.
Thank you very much, Anis and Rob. I have to say, I think this is one of the more important developments in terms of really enabling network operators to create the kinds of automation frameworks that let them really just make the network do what they need it to do for their environment and their use case in a way that really scales. So this is a fantastic contribution. Okay, next I'd like to welcome Bryan Larish from Verizon. Bryan's been working on NFV, which is super important stuff also. If you can imagine, if all of your applications were locked inside special purpose shiny metal boxes, you can only imagine how much carriers want NFV. So let me turn it over to Bryan. Excuse me.
Thanks, Ken. All right, so good morning, everybody. I think as Ken said, so I'm at Verizon, and I'm going to come at this probably from a different angle in terms of openness. So I'm going to come at it the angle of I'm a guy who's using open software. And now that I've been at Verizon, this is a couple of organizations I've been at where I've been through nationwide OpenStack deployments. And I'm talking to you because hopefully through that process, I've learned a thing or two that may be useful for you all. And when I started make these slides, I was thinking back in my mind to 4 or 5 years ago whenever I started with OpenStack. And sitting at my desk, somebody plopped OpenStack on my desk and said, all right, you're doing this now. What would have I liked to known back then, right? Because it's been a long journey, it's been a fun journey, it's been a productive journey. But these slides are basically written as if I could go back in time, what I would have told myself. And so if you're an enterprise person in the room, hopefully this will give you some ideas if you're trying to deploy OpenStack yourself or in the middle of an OpenStack deployment. If you are a service provider or a solution provider in the room, hopefully this will give you some ideas if you're trying to sell to companies like Verizon or the enterprises. And if that doesn't fit you, hopefully I at least say something funny that makes you chuckle in the next 20 minutes. So with that, I think what I want you guys to take away from this talk is really 2 things. One, there are a lot of benefits from going down the OpenStack SDN NFV path. I don't have a lot of slides on that, but in the 2 deployments I've seen, there are absolute concrete benefits, both in terms of CapEx cost and operational cost. Even if you're not operating at the sort of aspirational Google, Facebook, Amazon model, if you're living in the realities of an enterprise with a large legacy base and a large workforce, there are absolute concrete benefits that you can get. And so that's kind of takeaway number 1. Takeaway number 2 is as you're going through this journey, focusing on more than the technical piece and realizing that things are going to have to evolve architecturally will kind of help you through that. So that's kind of, what I hope you get out of this. Huh? This one. There we go. Okay. Helps when you pick the right one. All right. There we go. So vision. I have a couple slides that just tell you where Verizon's at, what we've been doing. I'll then go into specific lessons learned, and then also talk about some future directions. And so this first part of the vision is motherhood and apple pie. I think pretty much everybody in the room is probably nodding their head that, yes, this is why we want to do this. The second part of the vision, I think, is probably unique to a company like Verizon or any large enterprise out there. And that's, I have to achieve this vision while also supporting my legacy functions and applications in a cloud world. Another way to put this, I didn't put this on the slide because I would have gotten some weird looks from the Verizon public relations department, but I need to take care of my pets in a cattle world, right? I can't just get rid of all my pets. They're going to be with me for a while, so how do I do that when I move into this world of cattle and cloud? And the first thing we had to do at Verizon was change our mindset in terms of how we thought about data centers and how we thought about architectures. I'll talk about this a little more in the lessons learned, but I wanted to point out here that in our current architecture, you know, we put up this core network, we start attaching racks to it, and we're so focused on servers, we fill them up with servers, and when we need another server, or when the rack fills up, we add another rack, start filling them with servers. And that was fine, but that made evolution in introducing new technologies, especially on the network front, really hard. And so what we've moved to on this SDN and NFV architecture is a data center that's focused around pods and racks. And so when we go to look at deploying new services, we think about them in pods, and the pods may be different sizes, different configurations, but those pods plug into our core network, and then we look at evolving each pod at a time. So when we come to a new use case or a new technology, we can bolt on a new pod that gets us to where we want to be without having to deal with this entire mess of infrastructure that has all the different dependencies between it. When you talk about the actual pod design inside of Verizon, here's sort of a high-level architectural picture. I think this is probably fairly standard for anybody who's doing more modern data centers. We have a leaf spine network architecture. We're running OpenStack on the servers. We're actually using Red Hat's OpenStack distribution. On the network side, we're using big switches, big cloud fabric for the network. We have a little bit of Ceph in there. I think we made the choice to go to bright boxes on the network side instead of pure white boxes, just for comfort levels of our operational team. But I think this is sort of the standard thing that everybody's kind of talking about and trying to do. We actually have this deployed. I don't have today's numbers, but I know we have at least 5 different data centers up with hundreds of nodes in the data centers running. So with that, that's kind of where we are today. In terms of how could this process have been easier, I tried to break up the lessons learned into 3 categories, kind of the sort of the people, the process, and the technology. And so starting off with the people, this is obviously like the most important thing as you're going down this path. And I'm going to come at this probably from a little different angle as well. I know in the industry we talk about a lot about skills, and today's workforce has a certain set of skills that may not map to how we want to operate our networks. That's all well and good, but that shouldn't slow you down from doing these kind of things. A company like Verizon, I think last I heard we have 175,000 employees. That skill set shift's not going to happen overnight, and I think that's okay. It's not going to. It hasn't gotten in the way of us doing these new SDN things, these new NFV things. And one of the reasons for that is we talked about preparing the runway. And so what we mean here is the solutions that are available today are close enough to how the folks are used to operating that you can make progress and get stuff done. So if your folks are a flight crew used to landing airplanes, with the solutions and approaches that are available today, you don't have to tell them, look, we're not doing airplanes anymore, we're doing rocket ships, and everything that you learned is now out the window. What we have been able to tell them is, look, you're used to airplanes that looked a certain way with wings pointed back. I'm still going to give you an airplane, but it's going to look a little different. And So with that socialization has come much more acceptance on the operations side. Certainly it could have been better for us. I think if you are going down this path, this idea of preparing the runway with your operations folks, you cannot do this enough, right? I mean, if I could have, I would have had a chair sitting on, the operations floor with the people running it, preaching this message every day. But again, the good news is it's not, hey, all of that stuff you've been doing for 20 years, we don't care about it anymore, learn the new stuff or move on. It's been a message of, look, we're trying to make things better. It's going to look a little different, but it's not that bad. And you can handle this, and you can do this. So once the people are on board, an organization like Verizon and any big organization, we have our processes. We love our processes. Nothing happens without a process. Just for good measure, we probably make 4 or 5 processes for the same thing. And so one of the things that we've learned is those existing processes don't really accommodate how we want to do business in the future. And I think the first 2 bullets on here hit it perfectly, at least for Verizon, is because, you all see the commercials, right? Verizon, we whatever the studies say, we think we have a very good, very reliable network. So you can only imagine the processes that we have to go through anytime we make a change to our network or anytime we bring something new into our network. And a lot of those processes are focused around questioning the system operators and designers, how is this going to be reliable? And one of the things that we didn't realize up front, and we're sort of going back and fix, is as you talk through this reliability issue, you need to get the focus off hardware and into software. And when you have an entire process built around making sure you have triple redundant hardware and different geographic locations, and it's all about the hardware and how many 9s does your box have, we had to go back through and re-educate the process owners that, hey, we're going to do things a little different here. And we're not ignoring reliability, but instead of doing it like this, we're going to do it like this in software. And so please help us update your processes to make this a little smoother. I think in that same vein, one of the reasons we're going to virtualization, right, is to get more utilization of the hardware you have. And as part of our review processes, there was always a discussion about, do you have enough capacity? And have you over-provisioned your hardware enough so that if you get a traffic spike, can you do this or that? And it's been an interesting conversation with those people to say, look, we're going to this OpenStack model so that we can purposely over-provision or oversubscribe our hardware, take advantage of statistical multiplexing. And because we've done the planning properly, it will all be okay and we'll achieve that same level of capacity and performance that you're expected to see. This conversation has been really important though, right? Because if you think about, for an enterprise like Verizon, if you don't have that conversation and you just keep provisioning at the same capacity that you had been in the past with standalone physical boxes, you're losing a lot of that cost benefit of going to virtualization, right? It basically cancels that out. So making sure you address those reliability and capacity issues with your process owners, with the operations teams, is really, really critical here. The other one, switching gears slightly, is Verizon and most enterprises I've seen have an entire machinery built around buying individual servers. This has actually been a really difficult conversation for some organizations inside of Verizon, because the machinery they have to do this is so complex, very efficient. Like if you wanted a server, you can actually do this fairly reasonably inside of Verizon. But when you're talking about combining everything onto the same set of physical hardware, at that scale, you have to start thinking about racks. And so one of the conversations we've had to say is let's stop thinking about servers, let's think about racks, and let's create all our processes around racks. So instead of talking about the different servers that I'm going to buy and the server configurations, let's take that discussion up a level and talk about the rack configurations. So is this going to be a rack that's focused on a storage application? Is this more of a Hadoop application? Is this something that's going to be customer facing and running a lot of web service kind of apps? Those kind of things. And I realize this one sounds fairly simple, but until you have the conversations with people who have never thought another way, it turns out it's actually not. So lastly on the process, getting down into a few more technical details, one of the interesting things is in the past you had a server team and the network team. If a switch broke, you know what to do. Server broke, you know what to do. Now that I have this virtual switch sitting on my server that's performing quite sophisticated network functions, as you saw in the oven talk, or maybe a smart NIC on my server, you have interesting conversations about who actually owns that. And these don't have to be hard conversations, but they have to happen because when something breaks, this is, the vSwitch is on the server. So is that the networks team? Is that their job to troubleshoot it? Is it the server team? These kind of things have to be planned out in advance because today, there's a fairly clean line between server and network, whereas with these kind of technologies, there's not. And so having those conversations in advance as opposed to after something breaks is really helpful. On the technology side, there's a few things that I want to hit. So the first one is start easy, right? Don't pick your hardest workload that you're going to virtualize, your most critical workload. Start easy, something simple, something that's maybe suited to a virtualization effort, and build some early momentum. For Verizon, this was important, and this kind of bleeds into number 2, is because we're not re-architecting our applications, right? All those pets that I have in my network, I can't just tell my vendors, go re-architect everything because I'm putting it in VMs and containers and cloud and, just make it happen. Most of the time what's happening is they're taking their existing operating system that's on a physical box, plopping it into a VM and giving me an OVA or some kind of VM image that I have to run. And so start with an easy one that may be more amenable to that. The other thing we learned is that because I'm not doing this re-architecting, I need multiple server and rack configurations. So I think Facebook's talked publicly about how they have like 7 different rack designs based on what your application does. This is something that we actually had to move to that we didn't realize in advance. In the other organization I was with where we did one of these large-scale deployments, we were re-architecting and rewriting a lot of the applications, so it was much easier to just say, here's my standard set of rack configs, this is what it looks like, and go. With Verizon, it's been important because we're taking these legacy pets to actually think through what these different architectures should look like. The third thing is that you absolutely have to meter, especially when you're taking these legacy applications, moving them into the cloud. The vendors will a lot of times tell you, here's the kind of capacity you need in terms of vCPUs or memory or whatever it may be. But the reality is most of the time they don't know, especially because it's different for your environment. And so what we found at both the organizations I've been with, everybody asks for more than they need, which again goes and kills that idea of oversubscription and getting the most utilization out of your hardware. So you have to have some kind of metering capability in there so you can track what people are using and help educate them on what they actually need versus what they think they need. The fourth thing here is I called this information silos. I think that the point was hit earlier that every time you have a layer of abstraction, things get a lot more complex. And so what we found in these environments is the abstractions as they exist today don't necessarily talk well between each other when it comes to troubleshooting. And so my advice here is be careful of these information silos. Don't sacrifice ease of deployment or a solution that's available for troubleshooting on the back end of the operations side. And so for us, the way this sort of manifested in both deployments I've done is we actually picked a network solution that managed the virtual and the physical network from one place. That way we didn't have to worry about telemetry between the virtual and the physical network and trying to troubleshoot that on the fly. And then the last one is the architecture is going to evolve. And this is actually what drove us to that pod design I talked about. So initially we went in thinking, all right, we're going to have a rack architecture, a pod architecture, and we realized very quickly that we just didn't know enough to get it right from the start. And so going to this modular pod data center design has actually allowed us to go through multiple generations and multiple iterations of what those pods look like. Now I put notional on here because these are not exactly what Verizon's generation of pods look like, But hopefully this is the kind of representative example of things that we learned as we went through and that we modified. Right, so in the first generation, we started small, so we didn't really have many problems with single points of failure on the layer 3 network when it came to scaling up really high. As we started adding more and more, we realized, wow, the single point of failure is kind of a big deal. Let's fix that. We also started streamlining the installer, right? We again learned, even though we prepared the runway for operations folks, we can never do too much in terms of making their life easier. On the second generation, as we started moving more complex applications, network functions into our OpenStack environment, we realized that, hey, maybe we need to do some additional things with our network, both in terms of separating traffic to provide higher levels of service guarantee, as well as extending the network across multiple pods just because of the nature of deployment. The third gen, we've started looking at more advanced services, or we've said, hey, more advanced services would be really great here. We already talked about the network monitoring, I think, to death. But let's tap every rack. Let's figure out how we can actually collect that data and hopefully make some use of it to do better operations. How can we put multiple virtual networking solutions on the server to take advantage of these pets as they come about, and we can actually accommodate them on our systems. Okay, so that's where we are. Where are we going? One of the big things that we're finding as we move to these more complicated applications in our network or into the environment is we need more performance. And I put there on the bottom for both new and legacy applications. Right? So in theory, if you're re-architecting applications from scratch, a lot of this shouldn't be an issue because you can design your application to be scale out and you don't have these performance bottlenecks. Unfortunately for us, as we have these pets, we have things like there's lots of small packets, and they need to be at really, really high rates of packet per second, and we have to figure out how to do that. So we're looking at things like SRIOV, SmartNICs, DPDK, enhanced virtual switches, that whole gamut to really get these performance-critical VNFs into our environment. We're also looking at, in a related note, these pet VNFs require very high performance guarantees, whether that's latency, whether that's jitter, whether that's whatever it may be. And so we're looking at how can we actually do this, right? I mentioned in the previous slide that we actually created a separate network for our storage traffic because we felt like we couldn't get the service guarantees we needed. That hurt me a little bit as a network guy because I felt like we could, but we kind of lost that battle. So we're looking at how can we do that. The last thing is whether or not we should virtualize everything. So if you have lots of boxes that all your applications are trapped in, this is something to consider. We're going through. We don't have an answer yet, but it's something we're thinking about. I almost wanted to take this slide out because security has been talked about so much, and the reality is there's no good answers. But at least what I left it in here to just say one thing real quick. In terms of organizing principles and how we're thinking about security, we've come up with 3 things. Number 1, how do I harden the SDN NFV infrastructure? The good news is it's mostly Linux, so there's a lot of techniques you can reuse and lessons learned there. There are a few new things that you have to deal with, but it's tractable, hopefully. The second pillar, second organizing principle, is using this SDN NFV infrastructure to implement new capabilities. So now that I have this flexibility and control over my network, over my infrastructure, how can I actually implement new capabilities that were not practical previously? And then finally, how do I make sure that the virtual network functions or the applications I run in this network are secure? And instead of going through today's process where we get a box in the door, give it to the security team for 6 months, are there better things we can do so that we can sort of do this continued CI/CD on demand as things come into our network? So with that, that's my last slide. There's a lot of benefits. Hopefully I gave you some ideas, some pointers that will help you either provide us solutions or go down this journey yourself. Thank you.
All right, thank you very much, Bryan. Well, now we have a few minutes for a question and answer, so maybe we can get our speakers back on stage. please, if you have a question, raise a hand, find a mic, and we'll do it.
Okay.
And those two guys, yeah.
All right.
Before it was.
Yeah.
I'll get that one from you too.
Look at that.
All right. Any questions for our guests? Thank you.
Question for Rob and Anise. Do you really think the vendor-based CLIs and APIs are going to disappear in favor of OpenConfig, or will we be in a world where we might have to take advantage of both for a while?
I think we're going to take advantage of both for a while because it's simply for practical reasons to start with. So OpenConfig will not have every feature to start with. We don't have a model for everything right now. So there's lots of then discussion as to how you deal with that. Do you deal with that using vendor native models and then OpenConfig, or do you deal with it CLI with your existing template translation or whatever it happens to be? I think we'll end up with that hybrid. Equally, we probably will end up with some hybrid between OpenConfig and vendor models in the longer term as well, as there's specific features that some networks utilize which aren't covered in OpenConfig, and there's kind of a versioning question as to when do they get added. So I think we'll always be in some hybrid. One of the things that you can kind of observe from the overall service design perspective is if I'm writing a service and it needs to work on 10 different vendors, then I probably have to make the parameters of my service things that all those vendors support. And actually, when you go through RFP time, it's usually finding out, oh, I want to buy this box, but you don't support this thing, which I need because of this service. So you can kind of normalize your set of configuration requirements through intelligent service design such that you don't need to deal with that hybrid if that complexity seems to be too much. But I don't expect that there's one true way of OpenConfig. That's would be naive to assume that. But I think we're trying to get to having that cover the majority of the service configuration that we have, and then you can kind of work out whether you want to add vendor-specific things on top of that in the longer term.
Thank you.
Yes, Bruce.
I was initially very excited about the OpenConfig talk, and then halfway through I sort of found myself asking, given the sort of total failure of network management historically, why is this going to succeed where other areas have failed?
Yeah, it's a good question, and one that comes up a lot, actually. So there's no guarantee that this will succeed, by the way. But I think there's a bunch of things that have happened over the last several years that have made the chances better. I mean, one is that I think there's general consensus in the industry now, both among, not just among vendors, but also even among operators, that at least we have a data modeling language that we can use to start building things the same way that happens to have some features that allow you to extend it, et cetera, where we didn't have that before. Please don't misinterpret my remark as really saying that Yang is great or anything like that. It's got lots and lots of warts, but there's some common language now that we can work toward. Then if you look at vendors' activity, they happen to be building Yang models for their own internal data models also. So it gives us some hope that this direction is one that actually is possible. I think on the monitoring side, we've seen, the configurations, I think people have some systems that they've built together that work today with their multi-vendor shops that they're getting by with. I think that OpenConfig will really help there. But on the telemetry side, I think is where there is going to be a ton of momentum initially, and we've seen that already, right? So the idea that I could have the same kind of data with the same semantics coming back from multiple vendor devices is something that every operator immediately sees as a requirement and a need that they have. So that combination of having some tools in terms of software modeling languages and the pull from operators, or maybe the demand is a better way to characterize it, from operators to get some normalization across devices, I think is helping to at least improve the odds.
And if I just add one thing to that, I think, so having worked in environments where there's a huge pressure on cost per bit going down, when you start to get to the stage where introducing the next technology that gives you a cost per bit reduction is not, the thing that's making the timeline for that be long is not the vendor producing the card that you need, it's simply that your management stack can't consume it. then this is a really good financial reason for an operator to start to look at how do I really fix my network management. And I think OpenConfig kind of fits nicely into that from that perspective. So if there's a good commercial reason for it and you're able to enunciate that internally and explain why that's the case, then it kind of gives a focus to network management, which has been viewed as a bit of an inconvenience and a big spend in the telco world, to actually this is what's underpinning my ability to remain cash flow positive on some of my services. So that kind of focuses people a little bit towards maybe an effort that makes network management a little bit more sexy.
Sorry to ask you yet another one on the same topic. So it's kind of interesting that you can fiddle with the bits and bytes on the box. I get it. By the way, he and I tried it 18 years ago and we failed for the vendor reason. But ultimately, the problem is not that. The problem is, what are the services, where are they going, what boxes need to implement them, and do they all fit, and what to do when they break. That's the problem of the network. It's not going to fiddle with the box. So I get the need to get out of the humans, but the thing that I didn't see at all was where's the model of the services running through my network, and how do I transactionally make sure they show up?
So, I mean, that omission is, sorry, was there an addition to the question?
First of all, I would like to, it's related to that.
Okay,
I would
go
like
ahead.
to thank you very much for a great presentation. I think it's very impressive what you guys are doing. My observation is the following. We continue to see the network from the network point of view, from the bottom-up point of view. Somebody asked about, in the future, I'm going to use CLIs, and you said maybe yes, maybe no. I think the promise of SDN and NFV should be not just to replicate APIs for CLI-level commands, but to raise the level of abstraction. Remember Nick's talk. This is really the challenge of the future of network. We want to make the network as programmable as a computing system or general purpose computing system, but we cannot spawn a container and attach a subnet to a container, for instance. The subnet is layer 3 information, a container is more like layer 7. So I think it would be interesting to focus a lot on what is the level of abstraction from the application point of view that I need in order to work with a network. As Simon was saying, maybe a service model or something else. Just duplicating the same level of functionality with APIs is not going to solve our problem.
I don't think we should confuse OpenConfig's ambition with the overall ambition, right? So there is definitely a need for service abstraction. And the question really is, do you standardize that at this stage? And is it there an ability to do it? I think being able to push the configuration and get the telemetry from the box is an underlying requirement for being able to instantiate the service model. So, and actually there's some kind of commonality that's been established by what vendors support. We started this effort in the IETF to try and look at building a layer 3 VPN service model. And unfortunately, my name is on this effort, and I really wish it wasn't. Because seriously, it turns out that lots of operators can disagree about how they call the same thing. And this thing has ballooned into a hugely complicated model. It doesn't actually reflect the kind of underlying primitive that you have. It's not got any modularity. It's become entirely a product specification. So I think there's efforts to put in there to try and figure out how we can design some of those service models. Some of the container networking type things might be a good place to start because there's, again, some common technologies that are used underlying that might give you an idea of what the service looks like. But I'm not sure we're quite, well, from my experience of having tried it thus far, I'm not sure I would quite be ready to do it in a kind of standard way that we're doing with OpenConfig right now. It would be nice to do in the future, though.
And let me just jump in from an enterprise perspective, right? I think by and large, we're all in agreement on where we want to get to, but the reality is I'm here today and I need a transition path to get there. I can't just make that leap in one step. So even if the solution, let's just say OpenConfig is what we go with today, even if it's not perfect, if it helps me get started down that path, that's a win. That's actually real stuff that we can use and that can make our businesses better. So I think from an enterprise perspective, getting us going in that right direction is a huge, huge deal.
Yeah, I mean, it's a bit, I think, as Rob said, I'll just add one thing. I think it's a little bit, maybe, I don't want to say naive, but a little, maybe even, it is naive, I think, to think that we can get a bunch of operators who have vastly different tooling processes, business processes, to agree on what the service level APIs and abstractions should look like is very challenging, we found. I mean, this is why we didn't actually even try to solve that problem yet. We're starting at the infrastructure layer where there's a lot of commonality, a lot of common problems and challenges that all of the operators face. And then once we've got that solved, by the way, we have actually started having discussions about trying to model some of the layer 7 type of devices, because there's a lot of common functionality. There's not a lot of different things that people do there. But when you get above that in terms of services, end-to-end network-wide services, every operator does things differently, and they integrate with their own systems differently. Their notion of what the intent abstraction needs to be is different. So there's been a bunch of efforts to try to, standardize that. I think that they're misguided at this stage.
I think even agreeing what the modeling language would be at that layer is going to be a huge challenge.
Let's see if we can find a question other than OpenConfig. Haha, gotcha. Yes, please.
So I wanted to pick up on something Bryan said, and it does unfortunately touch a little bit on OpenConfig, but it's only because Anis put it out there. The notion that simplifying automation of CLI, fast CLI typing, to me is actually touching into the real challenge that we have in moving the industry forward, which is not greenfield recreation or creation of new technologies, but it's helping people actually evolve from where they are now to where they go in the future. And my question to each of you is, what do you think you're doing in your projects to actually help that iterative evolution versus this temptation towards technology-based revolution? Come on, you don't.
Any takers
You
on
look
iterative
stunned.
development?
Wow.
I don't want to answer because
Because you've been talking the whole time?
Go ahead, Anis.
Yeah.
Well, so I'll just say that I think that I think Rob pointed this out in the Jive example, right? What they've done, which is, it may be revolutionary to think of a common API that's all the way down on devices, supported across all the vendors, and fully implemented. But there are a bunch of interim steps that you can take to help you get there. One is, start to normalize the layer that interfaces with your management logic, your business logic, your intent APIs, whatever you're building in terms of automation, and what is there on the devices today. So today, we also do this through translations that we write and maintain, right? We have a bunch of configuration generation. We generate a vendor-neutral configuration for it, and then we translate it to the boxes. That's like a baby step towards this thing, but it gets us this vendor-neutral layer in between that now we can start coding to, and as vendor implementations emerge directly on the boxes, we can start getting rid of the task and burden of maintaining those. So I think we see a roadmap to get there. There's some complexity there, as Rob pointed out, with this sort of hybrid nature of, it's not all going to be there overnight on vendor devices. So we have more work to do to help sort of make that part incrementally deployable. But I think there's a really not easy, but sort of obvious first step, which is to have a sort of vendor neutral layer that clearly separates what's sort of proprietary and vendor specific from what can be made common.
So if you go to the OVS layer, so let's talk to Kyle, say, you have a nice standard semantic notion of what a service is, okay? And, so if you can get to that level of abstraction, can you model services in a way that dramatically changes this? By the way, so yep, I get in the OpenConfig world, we're maybe making humans a bit better or something, right? We're doing something. But in the OVS world, are we going like 10x that? That is, do we model services better? And would that be a better abstraction layer, for example?
I think, so for OVS, I think OVS has a pretty good abstraction for doing L3 and L4, and I think actually the logical flow that I was talking about in the database, I think is actually an improvement over the way that OpenFlow, if you're dealing with a raw OpenFlow, works. But that really only gives you L2 through L4, but you don't get stateful services. And so I don't think we have a great story yet on having a standard interface for those services.
So I want to actually answer Chris's question. I know we're going because I think fundamentally you bring up a good point, right? I mean, we're all doing this technology, we're creating these new things. So specifically in the case of Oven, let's look at that and what we might be doing. And let's tie it back to Bryan with OpenStack as well, and even what we're doing, I think, at IBM. So why did we do Oven? I think Justin alluded to it. Like the people that maybe were trying to orchestrate OVS were doing it a certain way. We kind of learned from everyone that was doing that, and we said, this is how we really want to orchestrate it to build virtual networking. So in the context of OpenStack, you say, okay, you have an OpenStack install. You might be using ML2 with the OVS Python agents or Linux Bridge or something. How could you fundamentally get to Oven? So we've actually made it so that we converted it back to an ML2 mechanism driver, which means in theory, we've provided the capability for a user who's using ML2 to load a new rack of servers with Oven, some number of them, and migrate themselves to that once it's ready. So from that perspective, maybe it's not quite the question you were asking, but I think it's a good answer nonetheless.
He can say so himself.
Over here.
Yes.
So at the risk of breaking from the norm, I'm going to try to ask a non-ocean boiling question. To Kyle and Justin, I saw this awesome slide on the Oven thing that said Oven is going to be available for the first time in non-experimental form.
Right.
A, can I use that term? Because that's awesome.
Okay.
And B, can you expand upon that? I mean, are you actually calling this production ready, or what is the exact state of the maturity of this?
So I guess I view it as, I didn't want to, I was trying to be a little careful about how I phrased it. I think someone like IBM could take it and they can make use of it. But they're familiar with, like as I mentioned, there are things like the database that, it's sort of hokey how it works right now. I actually don't think it's that much work to improve it. I think it will be fixed in the next 6 months. I think it's at a point where people can look at it, look at the architecture, decide if they think this is going in the right direction. But I wouldn't deploy it unless you have like developers and really understand it. Now I think that's going to change pretty rapidly. But I'm trying to be a little careful how I phrase it, because I also don't want people to look at it and say like, oh, this is a joke, and not understand that that there will be rapid improvement here. And also just the approach that we took towards a lot of this is we didn't want to, when we were designing Oven, you sort of have your idea like, oh, these are going to be the bottlenecks. But when we've designed these systems in the past, we've realized, well, we were often wrong. So we built something that we think had a clean architecture, and now we're going back and we're sort of cleaning up those areas that, that now we actually know, and we have numbers that show where the problems are and how we can improve them.
Right, definitely, and I think that ties into kind of the CI/CD that I talked about as well, that allows us to quickly iterate and consume these as well. But I think one of the other key tenets that you brought up was, when we looked at some of the early design decisions with Oven, there was initially last year, there was this push to try to make everything pluggable and abstract everything away. But I think it was actually the right decision to say no to a lot of that initially and say, we're gonna solve these things. We don't know where we can get it, but we think we can get it far with where it is. And when we hit that problem, we'll deal with it. And we have a way to deal with like changing out the databases and things. So I think it was, it's been good decisions along the way, I think.
So moreover, in any open source sort of development, it starts with experimental, then it goes to non-experimental state.
I was just trying to get them to quantify more precisely where they were, because non-experimental is, it's not going to blow up, we think.
Right.
So
you picked up on those keywords.
Yes.
Yes.
Do you intend to open source other management system you guys are building around it for your internal? Or you're just keeping that layer and keeping everything?
I mean, I think that's the layer that I was saying earlier, that we were saying that ties into a lot of the internal processes, abstractions, APIs, et cetera, that wouldn't necessarily work for Dave at Microsoft or Bryan at Verizon or other folks, right? So those layers, it's not clear to me that there would be a lot of ease of use or of value to folks outside. I think the places where we see the common problems across operators, we're really focused on open sourcing, not just the models, but I think as Rob alluded to, a bunch of tools, reference implementations. Think of them as sort of modules that you could use to help you start to consume OpenConfig models to build an NMS. I think that is what we are trying to open source. But I think the higher layers in the stack is when we start to get more and more integration with sort of internal processes and things where it, I think, makes less sense to open source that stuff.
We have time for one more question.
So this is a question for Sukhdev and also the guys who OVN. I'm sorry, I don't know your names. I don't remember them. So you talk about OpenStack, and there is a lot of discussion about the future of OpenStack. what's your opinion? So is OpenStack going to evolve? Is going to be a survivor? A lot of people are having doubts about it, so I would be interested to hear your opinion.
Well, you just heard Verizon going fully on OpenStack. Last summit in Austin, AT&T won the Super User Award. They went and they declared, 2,000 data centers and POCs. They're all running on OpenStack. There are very, very large deployments based on OpenStack. And as I see, I've been involved in it for the last 3-4 years. Kyle has been the same way. And it has been improving, and it has been getting stable, and it's getting fairly mature. But then again, it's beauty is in the eye of the beholder.
Oh, I should have warned you, Craig's sitting right there before you make any comments. I want to say that it seems like it's something that continually evolves to what its users want, right? And it's evolving in the NFV direction, seeing all the major telcos starting to use it now. So it seems to be a malleable tool that seems to be able to mold wherever people want to put it at this point.
All right. Big round of applause for our speakers, please.